Okay, for this problem, okay, it's we already know the part of the motion. The part of the motion is a curvilinear motion like this. Okay, and the problem is that the roller coaster is at point B. Okay, and it had a speed of 25 meter per second, which is increasing at at equal to 3 meter per second square. So as I mentioned it before, the speed that we know, which means it's represent Vt, right? Okay, because when imagine that, right, you drive the car, you know the speed. The speed is always the tangential direction, the speed in tangential direction only, okay, for the particle that's move along the curved path. And also for the acceleration, when you accelerate the car, when you drive the car and you accelerate the car, just only at that you can accelerate. You cannot accelerate the normal acceleration. Okay, normal acceleration is to change direction. When you change the direction, the friction between the wheel and the road, okay, is produce the normal acceleration to change the direction of your car. Okay, but when you increasing the speed of your car, you increase the tangential acceleration. Okay, you increase the speed, so then it represent uh tangential acceleration instead. Okay, so we would like to determine the acceleration of the roller coaster at this instant. Okay, because the roller coaster is moved along the curved path, so then acceleration is not necessarily this components. Okay, this is just only one component. Okay, it also has the normal components also, and we will use the formula in normal and tangential coordinate system. At we already know from the problem. We already know from the problem. We just only would like to know an. Okay, and an we already know that is equal to v squared. That's we already know it is 25 meter per second. And for this case, we just determine the radius of curvature at this point, at point B. Okay, and because this part is not a circular part, the circular part radius of curvature is very easy. It is constant. It is equal to the radius of the circular. But for this case, is it a curve? We have to determine the radius of curvature. That's we have to use this formula. Okay, we already know the part equation. That is y equal to x squared over 100. So the radius of curvature is determined from this formula that you have to determine for the first derivative of x and then second derivative of x, first derivative of y with respect to x and second derivative of y with respect to x. We require these two terms and then substitute in this formula, you obtain the radius of curvature. So for this problem, it's very easy to solve. We just starting with determine the radius of curvature first. For radius of curvature, we can determine according to the curve part, the curve function that we already have. We can derive for the radius of curvature by substitute x equal to 30 meter into the formula. We obtain the radius of curvature becomes 79.3 meter. Okay, and for the picture, I know that you should draw the axis like this. Okay, and for the acceleration, we already have the tangential direction and tangential direction of the acceleration. That is the problem is already given, is equal to 3 meter per second square. And then for normal acceleration, we determine from this formula and we obtain that is equal to 7.881 meter per second square. And so the magnitude is become 8.4 meter per second square like this. Okay. But the problem would like to know the directions of the acceleration also. The directions of the acceleration with respect to x-axis. So then more picture that we have to draw to make us understand the directions of the acceleration should be what? Okay, I'm drawing the path. This is the path for the roller coaster at point B. So then this is a tangent line of the path. Okay, tangential line. That's the if a match with the original one, it's maybe this line. Okay, the red one. Okay, and in order to make us more understanding, we draw the new one as the dashed line, dash green line. This is a tangent line of the path. Okay, and we already have two components AT. Okay, AT is in the same direction of the tangent line. So then AT is in this direction, and AN is normal to the tangent direction, and it's always centered toward to the center of curve. For this case, you will see that the curve is like this. So then the center of curve, it should be around here. Okay, so then tangential is this direction, right? And normal is should be this direction. So according to this, we have two components, AT and AN. So then the total one, it should be the green one. It should be like this. Okay. So according to this, we can determine the angle. The problem would like to know this angle phi. Okay. Sorry, not angle phi. Angle phi is you can determine directly. It is the slope, of the path, that is equal to arctan divided by the x. Okay, we already have the angle phi. And from the components, actually A is equal to AT plus AN, right? So then the angle alpha here is equal to arctan AN over AT, right? Okay, so according to this, we can determine alpha. Okay, after we have alpha, we can minus with angle phi. So then the angle theta, that's the problem would like to know, is equal to alpha minus phi. Okay, so according to this, may working out for the angle. Okay, so we determine the angle alpha is equal to 69.16 degrees. And also the angle phi is equal to 30.96 degrees. And then it means that the angles of the angle theta that represent the directions of the total acceleration with respect to x-axis, measure from x-axis is equal to 38.2 degrees. So that is should be complete for this problem.